Okay, so Algebra 2 students, here we are still in section 13.4, and what we're doing is just trying to figure out whether or not we can find some information about this situation. So we have triangle ABC, and we're given some information about that triangle. We know that our chart tells us when we're dealing with an acute triangle, there's a couple things that we need to deal with, or an acute angle. If A is an acute angle, I shouldn't say an acute triangle. If A is an acute angle, we need to kind of check on some information. And so we did by finding B sine of A and realizing that B sine of A was smaller than side A, and then furthermore, that side B is larger than side A. And so that is a specific category according to our chart that lets us know that we could have two different things going on. And what are those two different things? Well, those two different things really mean that this length of A could be either opened out this way or opened out this way, meaning angle B can be obtuse or acute. And that's the little thing that we need to work on and check with. So watch this. So we come down here and we apply the law of sines, right? And so we've done this enough that we know how to solve for sine of B. Let's put implies solve of sine of B. So we get 14 times the sine of 39 divided by 10 is going to give me the sine of B. And we're going to go one extra step, finding the inverse sine of this value here of 14 times the sine of 39. So let me copy that and then paste it right back over here. So this is what we're going to find. And once we do this calculation on our calculator, then what we're going to find is the value for angle B. When I calculate this, I'm getting approximately 61.8 degrees or 62 degrees. Okay, so 61.8, 62 degrees is kind of what we're working with. And that seems pretty straightforward, right, guys? And you're like, okay, fine. If that's 62, then you can find C. Where's this other answer coming from? So this is a little bit weird. And I say weird because you don't know this yet. Let me show you something real quick. So if I deal with the sine of a value x, so I'm here in Desmos, if I graph the sine of a value x, I know we've seen this, but we're going to talk about it more like in the next couple of days. What you're going to find is that the sine is not limited to just one angle. So if we were to find, I'm going to change this to radians, degrees, so that it kind of makes a little bit of sense. And I'm going to change the y-axis so we're dealing with big angles. Let's go ahead and do that. What I should have said is I'm going to change the x-axis so we can deal with some really big angles. And then we'll focus in a little bit and see what we got. So, all right, so what you realize is that the sine values will go from -1 to +1, right? And then the corresponding angles will kind of go cyclically. So for instance, you'll notice that the sine of 30 degrees, which is 0.5, is the same as the sine of 150 degrees. And if we were to draw it again, you'd see that it's a reference angle and all of that stuff. Why is this significant? Because with sine particularly, the repetition of angle values or of ratio values for angles is critical in that you could have two different angles within a triangle that has the same sine value. All right. And so in this case, we have an angle that is what, 62 degrees. And so our angle is 62 degrees. Let me go to 62 around here. So our angle value is 62 degrees, but it also has another value that has an angle measure that has the same sine value as, I'm trying to get it here. You know what I'm going to do? I'm just going to write down 0.88. So if I have y equals 0.88, I know y'all looking at me like, why is she doing this? Okay, so we see that's about 62 degrees is the sine angle, and over here we have another angle that would have the same sine value of about 0.8, so about 118 degrees. And so we're dealing with about 62 degrees and about 118 degrees. That's going to give us the same sine value. That's where we get those two different triangle solutions from for our problem. Let's go back to our problem. So I'm going to sharpen this point just a little bit more. Here we have that the sine is, you remember, whatever the y value is over r, right? So sine of this angle would be y over r, but there's also another angle that would have exactly the same sine value that is over here. How do we find it? I think that's really the question. How do you, if you know that there's another angle, how do you find it? And for us right now, what we'll say is, thinking of the fact that angle 62 is here, then this other angle would have a reference angle of 62 degrees with the x-axis on this negative side of the x-axis. So we would take 180 and subtract 62. So 180 minus 62 is going to lead us to that 118 degrees. So now those are the things that we need to consider. So we've got two distinct situations. We're about to end this section. Trust me, I'm not even going to do that next problem. So I'm going to erase this problem so we're not even thinking about it for this video. I think you guys can handle it anyway. And let's just finish up this problem that we're working on now. So we've got two situations. One where angle B is equal to 62 degrees, and the other where the measure of angle B is equal to 118 degrees. So these are the two scenarios that we need to solve our triangles for. So here's our setup. Let's consider what's happening. We have that angle A and side A aren't changing, right? That's going to be the same. Angle side B is going to be the same, but it's angle B that changes, and that's going to influence our values for C and angle C. So we're going to again apply the law of sines so we can calculate all the other values here. So since this is 39 and this is 62, what we're going to have to do is calculate angle C. And so clearly angle C would be 79 degrees here. And over here, if we're calculating the same thing, we would end up with a C value. Over here, we would get 23 degrees. And so, you know, that's just getting the sum of the three angles. And so now, if we're going to find side C, it's going to be a little bit different. I always like to use the thing that we started off with. So I'm going to start off with the sine of 39 degrees over 10 is equal to the sine of 79 degrees over C. And of course, we can solve for C by doing a little bit of algebra, getting C by itself, and we'll realize that C is equal to the sine of 79 times 10 divided by the sine of 39. And since that's calculated already, let's do the same thing over here. So again, sine of 39 over 10 equals the sine of 23 over C. And now we see that C is equal to 10 times the sine of 23 over the sine of 39. We're almost done, my friends. So C in this case and C in this case are going to be different, and they are. Either C is 15.6 or the length of C is 6.2. And I'm going to just show you guys a quick visual from your textbook so you can see what the look of the triangle could be. So again, depending on that value of B, we change the value of C. And so that's what we need to be sure of when we have two possible values for that B value. All right? I hope that made sense. I know that was a whole lot. We're going to leave the rest of this lesson for another time. Take care. Let me know if you have any questions, guys. All right. Bye-bye.